Hope we are live now. Are we live now? I think so. I'm just trying to check. Yeah, yeah. We are live. We are live now. So this is my first live. I feel a bit nervous actually. Um, feeling a bit nervous. Anyway, I hope I'll be trying to finish this without any big blunder mistakes. So I will try to finish what I thought. Uh, so in this stream, hope you have seen the stream title. Actually, I'm gonna show how to extract the passwords and other secrets that are stored in Google Chrome. TryHackMe has recently launched an incredible room. That room actually possesses some incredible concept. Actually, that concept was literally new to me when I was watching the Twitch stream of the security researcher Alhasred. I got to know that concept. He only taught me that concept actually. Uh, I'll let you know. I'll teach you. I'll tell you whatever the stuff I learned. So I'll try to convey it effectively, as effective as possible. Uh, what else? I think I have nothing else to say, so we can directly get into the stream. Let me switch this screen. Can you see the screen? I hope you can. Yes, you can. So here is the platform, TryHackMe. So I'm using this platform to learn the fundamentals. So it's an incredible platform, amazing one. The rooms that you find here teaches the basic security, basic information security. It teaches the information security from the scratch. If you know nothing, if you are totally new, or if you're totally a beginner to this, then I would recommend start. I would recommend starting from this TryHackMe platform, because as I said, it actually holds your hand and teaches the cybersecurity. So that's what I can say. Um, yes, apart from that, I'm just recommending you to explore this. Once you start exploring this, then you'll get to know what this platform teaches, what it offers to you. I think that's it. That is what I'm trying to say. Um, let me show that room actually. So here is that TryHackMe room. You can see the description. A password manager is only as strong as the password that encrypts it. You find that a malicious actor extracted something over the network, but what? Help us to find out. Looks like we are given some files and we need to do the analysis. We need to analyze that PCAP file. Hopefully it's a PCAP file. So we need to analyze that PCAP file. Then we have something to extract from it. So let's take that off and analyze what we have. I think that's the challenge in front of us. So I'm not going to do that in my base machine. I have a different machine. So it is actually a parent operating system made for the security researchers, made for the ethical hackers. So it's a It's a distribution exclusively made for that, and I'm about to use that distribution to do this exercise. So here is that. Just getting into the TryHackMe folder. Let me remove all the existing files of Chrome, creating a new directory Chrome. Fine. Okay, let me download that. I think I need to log in from here. When I was learning this Chrome machine, this Chrome room, I was able to learn. The challenge was really, I mean, it was really challenging. I had to do one decryption. It was really a challenging part. I had to do some reverse engineering also. So hopefully I'll showcase that part very soon. So here is the, I'll reset my progress so that I can answer all those questions once again. Let me download these task files. So we are given some files and I'm downloading it real quick. What happened? Able to download this. Something is fishy. What if I give download? Did I already download it in my machine? I don't think so. Not positive. What's happening? Something is odd. I'm unable to download these files. I'll check that real quick. It's an odd problem. I never faced this problem before. When I try starting machine of some other challenge, I'm able to do so. Look at it. But I'm unable to download this challenge file. It's really a basic problem. All right, I'll do one thing. Since I already worked on this challenge, I downloaded this file in my I think it must have stored in my VM's previous screenshot. So let me previous snapshot. Let me take that. I will. I'll try to shut this machine and restore the VM. Hopefully, it will give me the. Did I fail to allow this pop-up message? Oh, was showing the pop-up message all this time. Look at this. Huh. I'll start this parrot machine once again. Okay, better to restore this. It's a browser issue. I know this is my first stream, so I cannot expect more people to be here, but when I progress, when I make some useful content, hopefully people will involve in this stream. So here I am. Is it again a pop-up issue here? Now it is asking me to, it is asking download pop-up. Anyway, it works. It works finally. I'll remove this existing one. Maybe I'll create a folder like this. It was taking its time. All right. Anyway, we are able to download the file. THM TryHackMe. I'll remove this Chrome directory and rename this Chrome directory to this CD Chrome. Fine. We got the file now. So what are we waiting for? I'm just unzipping this file. As I was expecting, it's actually a packet capture. We need Wireshark to analyze it. I do have it, and I load no, I load the pcap file just like this. Okay, yeah. Now I have loaded the pcap file. Yeah. Are you hearing any sound at the background? Let me check. Are you hearing any noise or any sound at the background? Let me check. I think you, I think it is fine. Not hearing any noise at the background. Okay, we good to go then. Let's close this. I'll get into this VM in a full screen mode. All right, now you are looking at the packet capture, and here whenever I get into a packet capture, I usually check its file properties. So here is the file, and the first packet when it started, and the last packet when it captured, and it shows its hardware description. There were totally 4,800 packets captured, and so these are the stats, packet stats. So we do have these many packets to analyze, but we can just try to simplify this. We need not to analyze every packet. Uh, Here we check the file properties. Then next thing I used to check is the protocol hierarchy. If I go to this protocol hierarchy, look at this. We have the details from layer 1, the first layer. Okay, layer 1, layer 2, layer 3, 4, 5, 6, the 7 application layer. Here we are checking this stuff. We can see it handled the SMB traffic. We are actually having the SMB traffic, server message block. So it's a protocol used for the file hosting, the file transfer in Windows operating system. And we are up against this. We do have this traffic. I hope we need to extract some files that were, those files was transferred in SMB. Since we have this packet capture, we can able to extract these files from this pcap file itself. Okay. What else? We have some DNS traffic as well, some domain name domain names were queried, so we need to look at that. You can see it from the packet number 1. So we have SMB. You you can look at this keyword NTLM SSP. So let me tell you what it is. The NTLM SSP. If I search for the term NTLM SSP, then I can simply see the SMB authentication. I mean the handshake. Before it establishes the connectivity, it has to exchange some packets, right? So those packets we are seeing. So there are some authentication stuff. When I was taking up this challenge, I was just trying to uncover, was there any credentials exchange in this? And unfortunately, I actually uncovered a hash value, but unfortunately that ended up in nothing. That ended up in a blank value, I suppose. So I got some details, but I was not able to crack it. I think it is here, security blob. Session key. We have a lot of values here, but I was just trying to learn how to extract the password hash from NTLM traffic, and it eventually directed me to take a few values from this capture, and I was just trying to assemble those values in a manner so that we can just push it to hashcat and crack the hashes. I was just trying to do, but unfortunately I couldn't get any password. I think this one, NTLM server challenge. So to understand that part, you need to know how the NTLM communication occurs, how its authentication occurs. You need to understand its basics. And when I was trying to do this, I got to know this NTLM challenge series of yeas are nothing but the default NTLM server challenge value. So which will give you nothing. And we have nothing in this authentication traffic. However, we can able to extract the files that are transferred through SMB. So in order to do that, you need to go to this option file and export objects. Here you will see some protocols where you'll be able to extract the files that are passed through these protocols. So I can see SMB here. So when I click this, I'm able to see the list of files. You may see the file sizes, files with similar size. I don't think these are the different files. So these are, all these files transfer.exe are the same file. We can confirm this with the hash value. Hopefully I'll be able to download all the files in just one click with this option. And I'm just putting it in this folder. Before that, I'm just creating a folder files, and I am downloading every files within that. Files. So here I have a bunch of files. If I check SHA hash for those files, I can see all these hashes are same. So these files are the same. It's the same file actually, and these two are same. SRV SVC1. So these are the same file, and there is a file called encrypted files. So it's the same file actually. Okay, it's the same file. Well, we need not to have all those files. I'll just remove the unwanted files. Before that, let me rename these files. I'll just take the unique files from this. This file name is transfer.exe, and This one is WKSSVC. Not sure what it is, but let's find that in a moment. And this one. SRVSVC. And this one shows a different hash, so I'm downloading it. I mean, I'm just keeping it. %5 SRV C SR2. Yeah, I'm just renaming this to okay. I'm not sure what we have downloaded, but let's try to find that in a moment. Since it is a stream, I'm taking my time to do these things. If I'm creating a video, then I will cut, edit, and I'll crisp that video and add, but here it is not possible, so bear with me. I'll try to do it as soon as possible. rm-rf forcefully deleting whatever the contents beginning with %5c. Fine, now we got the files. Let me check the file type, what file it is, what sort of file they are. Encrypted file. We got some data, some encrypted data, but not sure how to decrypt it, but let's find that very soon. SRV SVC looks like some binary files, and here is one Windows binary transfer.exe. I can see it is portable executable. It's a console application, and Intel Mono.NET assembly. Since it's a .NET assembly, then I think I am able to disassemble it by using softwares like dnspy, ilspy. So that's what I'm gonna do in a moment. And here is another binary. So let's try to read the strings of these binaries before I'm just getting into that exe file. I'm using command strings. I'm just checking it. I don't have any crucial value. O2KP. Nothing nothing interesting in these files. Strings pipe WKSSVC. Nothing much. But when I try to read these files, I'll just show you a glimpse. It's a binary file. You will not get anything from these files in this state. Maybe we can try looking at this transfer.exe file. Since it is an exe file, I prefer disassembling this file in a Windows operating system. So let me do that in a moment. I just need to switch to another VM. Let me bring that VM to you. I hope you can see this VM now. So I opened Commander. Here in this window, you can able to use the Linux commands. Not sure ifconfig is possible. ipconfig 192.168.0.107. Before doing this disassembly, I need to transfer the files, right? So that's what I'm trying to do. Here, documents or what? I think I need to get into users, my users. I'll create a folder and name it YouTube, and creating one more folder and naming it Chrome, which is the challenge name. I got the path and moving to that path. Yes, we are that path now. IP config. I keep forgetting the IP. 0.107. I'll go to parent VM now. Here I'm ifconfig 0.109. So that's the server IP. So here from this files directory, I'm hosting these files. I'm using Python module, Python 3-m http.server. So which is a Python module, inbuilt Python module. By using this command, you can simply host a web server from anywhere in your file system. Okay, I think the IP is 109. So let me go to this commando VM again. And, commander, fine. I'm pinging 192.168.109. I'm able to ping. Let me grab those files. One file name is encrypted files, and another file name is transfer.exe. So let me grab that real quick. Which wget? Do I have that? Yeah, I do have it. http://192.168.0.109. I'm hosting this on port 8000, and the file name is transfer.exe. Yeah, I downloaded it. And encrypted files. Yeah, we managed to download those files to our Windows system. So here are the files. One is exe executable, and another one is the encrypted files. So looks like we are up against an encryptor. I'm not positive. Maybe once we use this the disassembler and disassembled it, we will get to know what it exactly doing. All right, I'll try opening the ILSpy. ILSpy is an application used to disassemble the .NET executables. Okay, fine. Now I already loaded that. Now I'm just trying to load it once again. So here is the file transfer.exe. Let me load this. Here is the file. It's loaded. transfer.exe. I'm just expanding it, nothing interesting, expanding all these folders. Let's see what we have. Fine. So looks like these are the file metadata. Here we can see its DOS header, COF header, optional header, import export data, references. You may see the details here, references, import table, export table. I think we can find it somewhere here. So these things will help to, these things will help in understanding the binary. What it does, it will give you some insight. When you look at this string, you may get some idea. So look at this. Actually, the string heap simply display the strings, the human readable strings that are present in this binary. And by looking at this, I can simply say it is doing some encryption, because here you are seeing the cryptography library. It is actually a library for .NET library. I think the C# library, to be precise. It's a .NET library used in C#. So by using this, I think it is doing some encryption. Some sort of encryption is happening. Let's see what is under the hood. I'm seeing the references, nothing else. Now let's move on to this main. Here I'm in program now, and I'm just clicking this main. So here I'm seeing the code block, what it is exactly doing. Looks like exactly what I said. It is doing some kind of encryption. Yeah, look at this. Let's see what actually it is doing. It is just pulling some basic libraries, and here is the library for cryptography, system.security.cryptography, and it is actually bringing a key value, bytes. It is assigning that key value into that variable bytes, and there is another value, looks like the IV value, because in AES, Advanced Encryption Standard, if you want to encrypt or decrypt something, then you need to have two values. One is key, the encryption key or decryption key, then IV value, initialization vector, I guess. Forgive me if I'm wrong. That is the term, I guess. And by default, what it was doing, it was just getting files from the downloads directory, especially files with the name files.zip, and it is just trying to encrypt that file. You can see username, potential username Hadri, but we are not going to use this name anywhere. We just need to recover this files.zip, because now we are up against the encrypted form of file. We are having the encrypted file of this files.zip. You can see this here. It is doing some encryption. I said it is AES, so it is calling that AES encryption from this library, and it is creating, look at this one, the bytes. As I said before, it's a key, and the second, the value in bytes2 variable, it is taking it as IV, initialization vector, and these two values are essential to do the encryption or decryption. And here it is creating the encryptor with this key and IV value, and it's creating a memory stream, I guess. In that memory stream, it's gonna bring the file contents, whatever the content present here, it is just bringing in this memory stream. Then it is creating a crypto stream. This is where it is doing that encryption, crypto stream.write. So as I said, this is where it is exactly doing that encryption. Then once the encryption is done, it is just dropping the encrypted content within this encrypted underscore files file. Okay, so this is the file. Now I think this is the file we have already in our hand, encrypted underscore files. So we know the key and IV value, we have the encrypted files. Then we can simply try decrypting this file. So once we decrypt this, then we will see this files.zip. It's simply a zip file. So hopefully it will have some juicy contents within this. So let's get into this. Encrypted underscore files. Fine. So this is the code actually. I'm just grabbing this code to create the decryptor. I'm not going to use any other language. Instead, I'm just gonna create one decryptor in C# itself. This is actually a actual C# script. By simply taking this and putting this in a code and tweaking some little things, we'll be able to create our decryptor. The language is C#. I'm just putting these contents here and I'm saving this file. Let me get into this actual path. Uses p3 rum YouTube Chrome, and I'm just renaming this file as decryptor.cs. Okay, looks okay now. Fine. Now let's try to tweak few things. Now this is the code for encryption. I need to create the script for decryption, right? So for that, let me keep these values as it is. Instead, this path, I'm gonna mention the path we are keeping these encrypted files. So here is the path. I'm just replacing this. Notice here we have 2 backward slashes to escape that backward slash. So I need to add one more backward slash here. So I'm pasting this. When I escape this backward slash, you can see these letters, the colors are changing in this first letter. So I'm just escaping this backward slash. So we have the path. So it is reading the file. It is reading this file. So here is the path. I'll mention this file name, encrypted underscore files. So it is reading this file in this line and putting this file content within this array. Okay, and it is also creating an empty variable bytes 3, and using this AES, it is creating some stuff. So it is taking the key, it is taking the IV value from here and creating the crypto stream. So here, instead I'm creating the encryptor, I need to create a decryptor, right? So for that, I'm just Google this and let's create some decryptor. Got it. AES decryption C#. AES class. This is the exact library that we called system security cryptography. So it's a C# library, and here I'm just searching for decrypt. Create decryptor. So here you can see the code which is actually creating the decryptor. So let me do that. Create decryptor. I'm just replacing this with create decryptor. These arguments are same, AES key and IV value, and crypto stream, memory stream we are getting this file content in this memory stream, and crypto stream. I think we need to tweak few things here. Let me try in this way. I'm just taking this whole line and putting this here, and again I need to cut this whole stuff and put this here like this, and I need to end this stream, I guess. because these are the changes I need to do. Earlier, when I was trying this room, I was just simply replacing this encryptor with decryptor stuff, and it was not working. But I need to add one more line here. But before that, let me change this output file name. So I need to save the content, whatever we are getting from this decryption, to the file called file.zip, and that's what I did. I just did. File decrypted and saved successfully. So I need to get this message once it is done. What else? I'm not the C# guy, so I don't know whether the indentation is matters. However, I'm just trying to close this crypto stream. Flush final block, I think. I need to add that line. Create crypto stream. Flush final block. Final block. Flush final block. C#. Yeah, I'm just flushing this stream. Yeah, I think we are creating a decryptor here. We are just bringing that encrypted content, and with this create decryptor function, we are just bringing that key and IV value as an argument, and we are applying the decryption process. Crypto stream mode, right? Memory stream transform. Looks like yeah, here in this specific function, we are getting this all these stuffs as an argument. Transform. We are creating a decryptor. Memory stream. We are bringing the memory stream, which holds this encrypted value, and we are writing all the content into the array which I created here. Flushing the final block. So looks like it is okay. It looks okay. I think I'm able to execute this. I don't see any error here. Error acquiring .NET. No, I think doesn't matter. Now, if I click CSC, I have this C# compiler in my Windows. To enable this C# compiler, by default it is disabled. In order to enable this C# compiler, you need to add your .NET path to this path environment variable. You can do that by simply going into this properties and advanced system settings, somewhere here, I guess. See, the advanced is, yeah, environment variables, and here you can add that. You can see the path environment variable in both system variables and user variables. So you can click edit and you can add this .NET path. So once you add the .NET path and restart your machine, you will see the C# compiler is enabled. You can enable C# compiler in that way. Yeah, I think we have the C# compiler. We have that decryptor also. I simply do this CSC and decryptor. I'm calling this CS. Getting some error, but let me see whether it created any decrypted files. No, it was not created any decrypted file. So let me uncover this. I just worked this decryptor before. Let me compare this with my current decryptor. So here is the program. Okay, they are putting everything within a class. So here is the difference. Private static void main. Here it is static void main. So this is the correct one. I think I need to bring the whole code block within this class program. So I think that's what I need to do. The remaining stuffs are okay. I'm just within this memory stream, I'm bringing the crypto stream, and within the crypto stream there are two lines, one to write and one to flush, and in the next line I'm just writing it to the variable bytes 3. I need to put it here. Let me bring this and add this here. So it looks okay at this point. Sync crypto stream. Fine, it looks okay. This code looks fine now. I think after this code block, I have these lines. So whatever the content in bytes 3, it is putting in bytes 2. Sorry, path 2. Yeah. Okay. So nothing but the output file. Okay. I think this is what I need to do. I'm just creating a class here. Class program, and copying this whole stuff, putting it in this class and removing this word private. Now it makes sense. I'll execute this decryptor once again. There is a syntax error. Really? Yeah, I think there is a syntax error. Expected. Am I closing every curly braces properly? Did I miss something? I don't see any error. No. Flush final block. I'm closing it properly. In which line I got the error? 23, 10, 25, 56. The 23, 10. Missed something. Probably the indentation matters. Let me choose this whole code block and keep a tab. Here, when I try doing this once again, it is expecting some indentation. Sorry, some bracket. open braces, where it expects that. crypto stream using memory stream. Okay, I think I got that. So here I need to mention that. Yeah. I think now I fixed it. Let me execute this once again. Flush final block. I think this casing is matters. Flush final block. Flush final block. Okay, looks okay. And using memory stream. Okay, I need to adjust this. I'll execute this again. Still I got the error. 53. $53. 29. 29th line. Flush final block. I made a blunder. The name memory stream doesn't exist in the current context. 2632. I'm just comparing with the correct code. 2632. Sorry, here 26 and 32. So these two lines. Indentation matters in C#. I'm getting a lot of errors because of this poor indentation. Memory stream doesn't exist in the current context. It frustrates me. Memory stream. I shouldn't add this semicolon. Now it fixes the error. Let me check this. Yeah, we got the decryptor. Now we managed to execute this decryptor, and we got this exe file. So once we compiled this, we got this executable, and when I execute this, it decrypted the file and saved it successfully, which means we recovered the file, whatever the file encrypted in that, by using the transfer.exe. we managed to uncover it. Okay, let me see that. Yeah, here it is, files.zip, and it has some files in it. So let me use it, the file command against it. Sorry, file.zip. It says it is a zip archive data. So hopefully by using the simple extractor, we'll be able to extract the file, extract all, and I'm just extracting it within a folder called file. Super, we extracted the file. Now we are looking at the let me just enlarge it. I need to enlarge this somewhere, somehow. Okay, so here it is. Now you are looking at a folder called app data. Now you know the challenge name is Chrome. The challenge we are currently doing is Chrome. I'll open this. TryHackMe. It's already logged in. No, it is not logged in. I'll switch to Parrot. Here, now we are in the challenge called Chrome. In Chrome challenge, here is the hint. A password manager is only as strong as the password that encrypts it. So looks like we are about to, we need to decrypt the password, the Chrome password. And to have that knowledge, to have that knowledge how to decrypt the Chrome password, you first should understand how it encrypts the data, how Chrome encrypts the data and stores it in the system. And here I'm going to tell you an important concept. If you know this concept, you will be able to apply this in many other places. Let me tell you what it is. The concept is DPAPI, Data Protection API. Data Protection API, it is actually an application programmable interface, as the name denotes. It is actually hosted by Microsoft Windows. It is actually the main API to handle the encryption in Windows operating systems, in modern Windows operating systems. It makes the developer's life easy. I'll tell you how. DPAPI, as I said, it's an API. It is an API used to do the encryption and decryption. And once, if you ask, hey, I need to encrypt this data, then DPAPI, okay, here you go. I'll get the data from you. I'll encrypt it. And I encrypted it. Here is the data. It gives the data back, the encrypted data. And that is how it is actually the encryption decryption works simply, in a simple way, in a DPAPI. And the Google Chrome actually uses the DPAPI master key to store its keys, its secrets. So I'll try to explain this. Give me a moment. I'll just try to draw and explain this so that you'll be able to understand. Let me get into this. I'm in the base machine now. Opening MS Paint. So here I'll just try to explain this. Okay. Okay. So let's say we have a Chrome browser, and we do have some secrets stored in it. It may be a password, it may be a cookie, it may be your form autofill data, it may be any other data. Some data is stored here. Let's say, yeah. So it stores some data, right? So what sort of encryption it uses? It uses encryption called AES GCM, I guess. GCM. I think that's the encryption used in this Chrome secrets. So by using that encryption standard, the Chrome encrypts its secrets. And to encrypt any value by using this AES GCM, it needs private key to encrypt or decrypt. So the private key might be some certain, some value, some kind of some secret value, the private key. And that private key has to be kept safely, so that nobody can able to decrypt, nobody can able to uncover that and read the credentials. And that private key safeguarded by the master key of DPAPI. DPAPI is nothing but data protection API. Hope you got that. The master key, it's an ultimate key used to protect the private key of the Chrome encryption. Hope you got that point. Not only Google Chrome, other applications like Internet Explorer, Wi-Fi passwords. Apart from that, few more applications use this DPAPI to store its credentials, to encrypt the secrets. Let me show that. Let me show that wherever this DPAPI is used. I'll try to show that here in a moment. DPAPI decryption. Hack tricks. I think hack tricks has some useful blog extracting passwords. So here it is. No, cancel. Okay, here is the definition. Data protection API is primarily utilized within Windows operating system for symmetric key of asymmetric private keys, symmetric encryption of asymmetric private keys. So by using master key, it symmetrically encrypts the asymmetric private key of Chrome or any other application. Any application, if you see, it might be using some asymmetric encryption. Asymmetric encryption is nothing but using two keys to do the encryption and decryption, public key and private key. And here is the definition. So that private key has to be safeguarded, and to safeguard the private key, DPAPI gives its master key. And an important point here, if a master key or a backup key is a backup key for master key. If a backup key or master key compromised in any attack, any cyber attack, then you may assume there is one user. First user, thanks. So what I was talking, there is, I mean, yeah, this DPAPI is used to protect the private keys of any encryption. And if that master key or backup key compromised in a cyber attack, then you may assume that the entire domain is compromised, and you need to reset, or you need to recreate that whole domain. You need to rebuild it from the scratch. There is no other way. If the master key and private or backup key is compromised, then you can assume it. You can say it's done. The whole stuff is compromised. That's why this concept is very, very important. Not only for Chrome, for any encryption that uses DPAPI. anything that uses DPAPI. If the DPAPI master keys are not protected properly, then you can say that whole stuff in a huge threat. And that's the thing. Yeah, let me tell you, wherever it is used, you can see Internet Explorer, Google Chrome's password, email, FTP accounts, Outlook, Windows email, lot of stuffs, lot of applications, lot of things that we are using in our life, in every day, is protected by DPAPI. Windows Vault, wireless networks, the Wi-Fi passwords are stored in that way. .NET, the RDP sessions, some credential managers, Skype, MSN Messenger, lot of stuffs. Okay, so that's why I'm just telling, if you know how to grab the master key, or how to grab the secrets of DPAPI, then you can crack a lot of things. So it has a vast scope, so you'll be able to crack a lot of things if you have an understanding. Okay, that's what I'm just trying to say. You can see, so these are the commands from command prompt and Mimikatz. If you are running Mimikatz in your machine, then it is very simple to extract the password vault. So that's what these commands denote. Okay, so let me go to this commando VM once again. So I'm in the commando VM. Now let's see the decrypted file. So we decrypted a file. It actually brought me to this app data folder. When I open this app data, I can see local, roaming, local now, these things. If you are using Windows operating system regularly, then you might know this. These are the hidden files in Windows OS by default. If I go to any Windows operating, if you go to any Windows operating systems, in your users directory, you can witness this. Think in users directory, yes. As these files are hidden, you need to here is the file, app data. So we are actually having this folder. This content creator actually extracted this folder simply out of a machine that runs a Google Chrome, and he actually gave the Chrome vault simply. We need to check whether it has the master key. To check that, we need to go to this roaming folder, Microsoft Protect. As I said, this DPAPI is actually managed by Microsoft. In Windows operating systems, it is predominantly used. And if you move to this folder, Microsoft Protect, in roaming folder, within the roaming folder, Microsoft Protect, then you can witness this DPAPI master key. So here is the master key. So, and I mean, here is the master key. If the folder name, if you see, S-1-5, which is nothing but the security identifier of the user. Whoever might be the user, that uses SID is this value, and here is the master key. The master key is present within this file. If I try opening this with some file editor, some text editor, you don't get anything because it is actually an encrypted file. Not an encrypted file, it is actually a key. An encrypted file, yes. To be precise, it's an encrypted file. All right, I think now we can try decrypting this key. So in order to do that, I need to and one more thing I forgot to explain. So in order to decrypt that master key, you need to know the user's password. Whoever might be the user, you need to know that user's password, because that master key is actually encrypted by that user's password. In this simple diagram, I explained how the encryption is happening, but I never said how this master key is encrypted. This master key is also encrypted with the user's password. So by using that user's password, this master key is encrypted. And to grab that master key, you need to know that user's password. Okay, if you know that user's password, then it is possible to extract the master key. Once you got that master key, then you can decrypt whatever the data encrypted by using DPAPI. Okay, that's the concept. I'll go to this. Actually, I came across one incredible blog published by Hack the Box. So I'll refer that blog while doing this. I actually referred it while doing this box, while doing this room. So I'm going to do that once again. And to grab the user's password, because I said we need the user's password to decrypt the master key, but we don't have that user's password right now. But we can extract the user's password hash from this master key file itself. And in order to do that, I need to download a file called DPAPI to John. It's actually a Python script, and I need that Python script. By using that Python script, we already have that master key file and also the SID of the user. We can simply put it as the argument to that script and extract the user's hash. Once we extracted the user hash, it is possible to do the password cracking. If they are used some simple password, then it is possible to crack the it is possible to extract the it is possible to crack the password. So fine. Now let me go and download that file. The file is nothing but dpapi mk2john.py. dpapi mk2 john to John. So here I have this script. So this is the script I need. I'm in the commando VM right now, downloading this file. It's a raw file. Yeah, downloading this file, dpapi mk2 john. Okay, it's in this download directory. Just moving it to the current directory. Okay, fine. Now I think let me review this whether dpapi mk2 john. I think it is Python 2. Let me check that same. Usually to check whether it is Python 2 or 3, you can refer the print statement if any. So Python 3 script, I guess. All right. Let me try and execute this. I have Python installed in this commando VM. Yeah, it's Python 3 it is. And clearing the screen. The file name is dpapi. Okay. Python. Please install crypto package. So we need to install the PyCrypto package. What package we need? We need PyCrypto package. So this is what the error we get. It's an import error. Since we don't have this encryption library installed in our machine, it is just giving this error. So let me try installing this pip3. Is it pip3? Yes, it is. pip3 install pycrypto. What happened? Installing backend dependencies. It's stuck at this point. We got some error. Looks like failing building wheel pycrypto. When I Google this, I'll get the reason. Yeah, pycrypto is no longer working. Use pycrypto dome instead. So we need to download this pycrypto dome library instead of pycrypto, since it is obsolete. Pycrypto dome. Let me install this. It will succeed. It will succeed. Let's wait. It is installing. Yes, it is installed now. I'll go and execute this Python script now. Yeah, it needs the master key file and SID to extract the hash from the master key file. So I hope it is clear. As I said before, it is essential to extract the password hash from this master key file, because it is blended within this master key file itself, the hash value. So if you find a way to extract this hash out of that key, master key, then it is possible to crack the password. If they used a weak one, they use a weaker one, then yeah, I think that that's the stuff we are about to do. We managed to download this, and it is asking us to put the master key file and also the SID. Do I have any help menu? Yeah, -s or -SID and mk or -master key to put the master key. All right, now let me get into this. SID, I'll copy. Okay, I'll loading the master key file. Fine. SID. I pasted the master key. Sorry, I pasted the SID just now. And then I need to mention the master key. We need to mention the correct path. So within this path, and master key, here is the master key. I'm just enclosing it in a double quote. And what else? -- content. I'm just mentioning the content. Okay, it is actually a local. If the machine is in a domain, or if the machine is a standalone machine, based on that we define this context. For in our case, it is local, which is nothing but a standalone machine, so that I'm giving the context as local. So once I define the context, I can simply redirect the output to the hash file equal to local. Okay, now I'm redirecting it, that this hash value to a hash file. hash.txt. Looks like these details are fine. I'm just clicking, just entering. Let's see whether it will extract the hash value. Not responsive. It's not responding now. What the heck? Yeah, no error. No error has been triggered. So looks like it is done. We have this hash. I'll open this in Notepad. So here is the hash value. It's a DPAPI hash. Now we have the hash value, and if we have that any password cracker like Hashcat or John, it is possible to crack the hash. Okay. Now let me bring this hash value. Do I have John here? No, I don't have John the Ripper installed here. However, I can simply pass this file to my parent machine to find the password. Okay. Python -m http.server. Yes. Now it is listening. I can go to this parrot, and here I can download that. Okay. Here, let me check its IP once again. It is 109, so the server is 107. Wget http://192.168.0.107 8000, and the file is hash.txt. We got the file. Cat hash.txt. We got the hash value also. Now it is cool. I mean, it is very simple. We just need to use our John the Ripper to extract the hash out of it. I mean, extract the password out of hash. Not extracting. It is actually a password cracking. It's not possible to reverse any hash. So what it will do, it will simply take every password from that password file, and it will do the hashing. It will compare the hash. If the hash matches, then it will say that's the password. That is how the password cracking works. Word list. Word list equal to user share word list roq.txt. We have the roq.txt, but it is unzipped. I need to unzip this. Let me create a tab, and I need to unzip it. So for that I'm using unzip user share word list roq.txt. Permission denied. So I'll go to the front and apply sudo. It is done. Let me call roq.txt now. It is done. We could straight away it cracked the password. So here is the password. The password is bubbles. So this is the password of user. Now we got the master key, we got the password of the user, and also we got the file, the password vault we need to extract. Now why are we waiting? What are we waiting for? We can just go and do that cracking. So here is the first password we found, bubbles, and that's the correct answer. Okay. Then the next question, what is the URL found in the first index, password found in the first index, URL second index, password in the second index. If we are able to uncover the password manager, then it will answer for the remaining questions. I'll tell you where it is stored. We are in the file, app data, local, Google, Chrome. Within the Chrome, there is a folder user data, and you can see a file called local state. This is where in this folder, in this specific file, local state only, that Chrome's private key is stored. As I said, this private key is encrypted with the master key. Whatever the private key, it is encrypted with the master key of DPAPI. We got the master key of DPAPI. Now we can simply decrypt this file and find the private key of Chrome. Okay. Now we are just trying to decrypt this local state file. Once we decrypt and found that private key, then it is very simple. We need to grab the password vault. For that, we need to go to this default directory, and within this default directory there is a file called login data, which is nothing but the password vault. Okay, this is the password vault. Fine. Now let's go and let's go and crack this private key. Okay, so to decrypt the private key, we may need to use Mimikatz, or we can use Impacket. I'll try using Mimikatz to just simplify it. I'll go to this folder. I think we have Mimikatz here. Mimikatz. Yes, we have Mimikatz. It is not installed. Can we try to install Mimikatz here? Just downloading it from Git. Mimikatz Win32. So we have the Mimikatz here. It is blocking actually, but I need to allow this. Threat protection is turned on. Real-time protection is turned on, so that's why it blocked. I'll it removed it. Oh gosh, it removed it. Remove that Mimikatz. So I'll delete this Mimikatz. Yes. Let me bring this once again. Win32. So rm-rf mimikatz. Yes. Now still we have that. Okay, let me get into this mimikatz directory. Here I'm giving the git clone. Now it downloaded this. Yeah, I'll go to this mimikatz folder again. cd win32, and here I'm calling the mimikatz binary. Yeah, now we are in mimikatz. Okay, cool. Can I open a tab? No need. I can. Sorry. Okay, I think I can open one more console. Fine. We have this mimikatz now, and DPAPI : master key. We need to mention this because by using master key, they are going to extract the password of, the private key of Chrome, right? So for that, I'm just calling this input. Here in input, I need to mention that that master key, the location of that master key. So let me do that. Here where it is stored: file, app data, roaming, Microsoft protect, and this SID. This is where it's stored, and I need to mention this here. Can I mention everything within quotation, double quote? I think I can do. Then I need to mention the SID, the SID value, the security identifier of a specific user. I can mention that SID, and that SID is okay. I think before that I need to mention this master key. Sorry, master key. Here it is. Copying this and putting it. Okay, and SID, I can simply copy this value. Oh, I messed it totally. (98212A44) (98212A441580). Looks okay. And password, we already grabbed the password. The password is nothing but bubbles. So here is the password, and I need to mention protected. It looks okay. Let me give the enter. Yeah, we got that master key with password, protected user, and here we got the key, I guess. Yes, We got the key. We decrypted the master key now with the user password bubble. So this is the master key. This is the DPAPI master key. By using this master key only, we can extract the private key of any encryption. Okay, that any encryption that is encrypted with DPAPI. So this is the master key. I copied this. I'll put it in a file so that here is the master key. Then what else? I have a program. That program we need to, by using that program we need to what can I say? Before we are using this master key to decrypt that private key, we need to convert that private key into some format. For that, I got one program, a simple Python program that actually changes that local state file into a certain state. That state can be used to, in that state, in that format. If we can able to convert that local state file into a certain format, then we can use that format for the direct decryption. Okay, I got that content. Let me open a file and select a language. It is actually a Python file, Python, and I'm putting that content in JSON base64. So whatever the content in this local state file, we are just opening it and we are doing some conversion, and we are just writing that converted data to this file DEC_data. Okay, so it is doing some format change and it saves in that file. Hope you got that. And let me grab this local state location. As I said before, it is in that local file, Google Chrome user data. Here is the local state, and I'm just taking that and putting in this. User data, local state. Okay, now we got that local state file content in this program. I'm not going to change these things, and this also I'm saving this content in this DEC data file. So let me save this as format changer, maybe format changer. Okay, now I am changing its format. Fine. What else? I think I need to execute this straight away. Format changer. So here is the file, Python format changer. Syntax error, Unicode escape, codec can't bypass bytes. Let me tweak this code a bit. Okay, it was unable to escape this. So if it has to escape this, then I need to give a path like this. Now what if I try to execute again? Once again, I got the error. Okay, I'll remove this. And within a folder file, app data, local, Google Chrome, user data. Okay, looks okay now. I will go and execute this again. The first line itself I am facing the error. Do I need to escape all the backward slashes? Maybe. Yeah, looks okay. Let me execute again. Yeah, it executed properly now. I also got the file DEC data. Yes, we got that format. We formatted that local state file to in a specific way so that we can simply use mimikatz to decrypt that local state file and extract that private key. Okay, now let me, yeah, let me go to that mimikatz session. Here DPAPI DPAPI :blob and master key once again, and we already got the master key with us. Let me take that master key simply and put it here. There is no space or special characters, so I need not to enclose it in a double quote. Then I'm giving the input. I need to bring that file. So we just changed the format, right? So we need to bring that. Let me take this path, DEC data. DEC underscore data. Yeah. So here it is, bringing this. Fine. And now I gave this input file and I added this its master key, and also I'm mentioning the output file. So this is where the output is going to get stored. Mentioning an output aes.dec decrypted file. I'm just mentioning its file name. Looks fine. So when I execute, it must extract the private key of that Chrome and store it in this aec.dec. So let me give enter. Some error, some weird error I got. Weird error I got. Yes, I'll try to escape this with another backward slash. Let's see what I get. What this error is all about. It's a mimikatz error. It's a sandbox analysis. mimikatz.exe. I'm getting this weird error. Not sure why. DPAPI :blob, then master key. Okay, with this step. Until this step it is fine. Grabbing the master key, copying it, and adding the master key. Then I need to put that DEC data. Maybe I'll try to bring this file. I'll try to copy this and put it in the Mimikatz directory itself to avoid the unwanted thing. And here in putting DEC underscore data. Okay. Out AEC.DEC. AEC.DEC. Cool. We got this. We got that private key, Chrome private key. By using this master key, we were able to decrypt the private key of Google Chrome. Like this, if any application that uses DPAPI, you can able to extract its private key if you know the user password and also the master key. Okay, so this is how you need to do. Hopefully, yeah, we got that AEC.DEC. So here is that. I'm just catting it. I'll try to cat it just to ensure cat AEC.DEC. Yeah, we got that private key of Chrome. Good. Now we just need what we just have one more step, the last final step. In that step, we are going to execute a Python program. I'm not going to spend time explaining what it does. I'll simply maybe I'll try to give the link of that blog which I referred. There you will find that Python code. That Python code, if you simply execute that Python code by putting the Chrome's private key, then it will drop all the secrets in a plain text. I'm not going to explain, as I said, I'm not going to explain what it does. I'm not going to write the Python script now. I'm running out of time. I gotta go. So I'm just creating a file, selecting a language. It is Python. And, I brought this. Here it is actually it embedded that path where that login data stored, the Chrome vault. I'll just explain. Simply, I'll go through the script and let you know what it exactly does. So let me go to this main function. In this main function, there is the first function call, get secret key. So here is the function call. It is getting that secret key, AEC, the decrypted secret key, and it is opening that file, and it reads that file. Okay, and the next one, the Chrome path to login the database. So here is the file, login data. That is nothing but the Chrome database, an encrypted database. So you need to know, you need to get into that path. So let me go to that folder, local Google Chrome user data default login data. So this is where this login data password vault is present. It sizes 46 KB, and once it gets into that database, it gets the DB connection. It tries to connect the DB. How it tries to connect it? Because it is simply, it is nothing. I mean, the database type is SQLite. The Chrome uses SQLite database. You can see this. It is using SQLite connect to just try to. I mean, it just uses this SQLite connect function to connect the database. So whatever the database called here, it tries to connect it. Then it just putting that session in this connection variable. Then there is an if condition. If there is a secret key and there is a connection, then it try to execute this statement. Select action URL and username and password column from table called login. Since it is an SQL database, it is actually a relational database. Data are stored in an organized way. So you can use this select statement to grab that data. And these are the things to, there is a function enumerate, and here, if there is no URL, if there is no ciphertext, or if there is no username, then it is not empty. If the URL is not empty, if the username is not empty, if the ciphertext is not empty, which means there is if there is no blank entry, then it just try to decrypt that password. Decrypt password, ciphertext, secret key. We have the secret key. As I said, that Chrome passwords are stored in an encrypted format, and that encryption is done by the secret key. The secret key we already have. We already extracted the secret key by using the master key. So we have that secret key, we have that ciphertext. Simple. We can just decrypt the password, and finally displays the password. So here is the decrypt password function. So it decrypts it by using this decrypt payload, cipher payload, generating the cipher, AES key, and IV. So it grabs this value from the secret, this AES decrypted secret, and it does this decryption. So this is the script. I just explained it. Let me save this Chrome password extractor. Saving this. Fine. We got that, and we got this path also. So let me go to this script and tweak few things. I need to grab, so where this password extractor is stored. It is stored in this Chrome folder, and I'll just paste this. It is in the Chrome folder, so I'll remove this. File. I'll add / to escape it. Now we got a way to read this login data. Then I think that's it. We can simply save this and execute it. If everything goes well, it will just dump the password, the encrypted password. The AES DEC is not in this base folder, so that it is not in the base folder, so I need to bring it to the base folder. AEC DEC, Control X, not Control X. Maybe I'll simply copy it. Here, yeah, I brought this file also. Now we good to go. Okay. Python Chrome password extractor. No module found. Win32 crypt. All right. I need to import this module. I can simply do this by pip3 install. Couldn't find the version. Satisfy the Win32 crypt. Okay. Do we have Win32 in our parent box? Pip3 list pipe grep Win32 crypt. It's not there, but we can install it, I guess. Install Win32 crypt. Sudo Oh, I'm getting some error. Chrome password grabber. No module name Win32 grid. Pip install. Okay, I need to use this one. PyPy Win32. Okay, there I made a mistake. Now it will resolve the issue. PyCryptoDome. CryptoDome. Already satisfied. We'll take this error and Google it again. Hopefully we'll get some GitHub. Yes. PyCryptoDome. PyCryptoDome. It is actually installed. Yes. PyCryptoDome X. We need to append X. Looks like. Let's see whether it resolves our issue. No such file. aes.dec. aec.dec. We have aec.dec. Okay, aes it has to be. Move aec, not aes.dec. Fine. Sorry. mv. Okay. It executed. But where are the encrypted decrypted passwords? Just debug it. Let me try debugging it so that we can find where the issue is. No, I need to switch to directory. YouTube, Chrome. So from here, what if I no error, but at same time no output? I'll debug Python debugger, Python file. I'll set a breakpoint somewhere over here. Index. I'll set breakpoint here and see whether we are getting that debug console. Here I'm just trying to read connection. SQLite connection object. False. So looks like it's not at all recognizing this path. Looks like that's the error. I'll do one thing. I'll just grab. I'll just try to grab that load. User data default. Yeah, this login data file. I'll just grab it and put it in this path itself to avoid the unwanted stuff. Login space data. Simple. So this is the file now. Okay. Good. Now I'll go here and try running this. Still not getting it. Still not getting it. Okay. Run and debug. Debug console connection. I'm not sure what happened here, but I'll set another breakpoint. Secret key indexer, URL username, decrypted password. So here at this point, I will set up a breakpoint. Continue. I think this one. Remove this breakpoint and run this. The program is not at all reaching this breakpoint. Is it reaching this point? It reaches. Okay. It reaches this value, this part also. Reaches this place. Reaches this place. Reaches. And when it reaches this decrypt password, goes to this function cipher text, generate cipher, initialization vector, secret key, decrypt payload, decrypt decode, decrypted pass. What if I mention a statement like this? Will it get into this loop? We got the password. Look at this. I just did a simple modification here. Earlier, the if condition was URL not equal to empty, username not equal to empty, and ciphertext not equal to empty. But here URL, username, password value. URL, username, ciphertext. So I think it made the magic. I just switched it to true. Then it got into this if loop, eventually decrypted and printed the output. Okay, I think that's it. So let me execute this once again. We got the password. Sequence 0, username is administrator. This is the password. Sequence 1, username is Chrome. This is the password. So we have everything to answer the questions now. Let me get into this. Yeah, here URL. What is the URL found in the first index? It asks URL, what it is. It asks URL. I don't see it right here. I don't see it right here, but can I get it? Can I get it? URL, username, decrypted password. Decrypt password, ciphertext, decrypt. So here there's the decrypted password. Decrypt payload. Cipher decrypt payload. URL, username, password. Decrypted password. Username. URL. Unfortunately, it is not showing the URL. Once it decrypted, just connecting that database and executing this action URL, username value, password value from logins. There is no value in action URL, then might show empty. But if it is wrong, if this specific column name is wrong, then do we get this empty value, or will it throw the error? It asks for the URL, but I don't have the URL right now. How can I find it? URL column in Chrome database. URL column in Chrome login data DB. Username stored in username value, username underscore value, username underscore value, password underscore value. Just nothing but the password from the vault. An action URL. I suspect whether this column is right or not. Origin domain, here they gave the domain where the user entered his credentials and logged in. So this might be the answer, origin domain. Let me switch this origin domain and execute this again. Will I get no such column, origin domain? So there is no such column. Action URL. So this is not the column name. We are getting the error. Select all from URLs. Is it storing the URLs in a different database? Because I'm just seeing the values from the login table. I'm just seeing the values from the login table. Is it storing the URLs in a different table? What if I try to execute all? Since it is an SQL query, I can just tweak this and execute this. Hopefully it will give a valid outcome. Look at this one. Now I got the URL, but I don't see the username and password. If I be specific with the username value and password value, I can see no. I think I need to mention this action URL also. Now I can see its username and password. Anyway, we got what we want. We got the URL, we got the username and password. So these are the things we extracted from Chrome database. So hope we learned some incredible stuff. So let me put this flags in TryHackMe to finish it. I think I need to defang it. How can I defang this? To defang that, I need to go to CyberChef. Here I'll get an option to defang any URL. Defang URL. So here is the defanged format. That's the correct answer. And getting into this and seeing the next URL, worksite.thm. Putting this in the defang page. I got that as well. Then what else? Password, right? Yeah, I have done this managed to accomplish this challenge. Uh, yeah, we did this. Yeah, I think we are live more than 2.5 hours. So in this 2.5 hours, I struggled a lot. It's my first stream. Um, I prepared this challenge before itself. Till that password cracking, I prepared. Then I knew what I had to do. So I managed to accomplish this now. Um, what else? I gotta go. I gotta go. I don't have time. I gotta go. Uh, Hope you really enjoyed it. I'm not sure. I took a lot of time. I took a lot of time. My communication was not good as it was, and it is more than 2.5 hours, and I did some cool stuff. I hope I need to go and have some family time. I need to go and have some family time. Hopefully, we did some good job, some productive time we spent. This is my first stream. I'm seeking your support. Support my channel. Uh, I'm here to do more and more technical content. For that, I need your support. So your valuable support is required for that. And I'll catch you next time. Another exciting one. So let me close these things, shut down my VM. Yeah, shut this down. I'll close this also. So this part is very, very important. If you want to learn DPAPI, then try to understand. I mean, if you want to know what is DPAPI, then try to understand how it encrypts the data. So if you know how it functions, then it is easy to do the forensic analysis. When you have this vault, when you have the master key, it is possible to extract the stuff. In this challenge, I got the file from another system, so I was not able to use the binaries like sharp chromium. I learned a trick from Alhasred. In his stream, he was using sharp chromium binary to extract the credentials directly from the machine vault. Actually, he was doing one CTF. In that machine, he got that user password, user credential, user privilege. Then he was trying to escalate the privileges, and once he found that master key in the path, he decided to use that sharp chromium binary, and he used that binary. He simply executed a single command, sharp chromium full or logins. I guess those are the arguments. He used that argument, simply dumped the database. So the sharp chromium, that binary itself, did all the stuffs that we just did. Extracting the master key, extracting the private key from that login data blob, not login data, that blob login state. From that file, he extracted that, that binary extracted that private key. Once it got the private key, it is super easy to extract the password, the plain text password. Okay, so if I was in a live machine, I would have done that, but since it was a forensic assessment, I got the file from another system, I had to do these many steps. So we did one TryHackMe hard challenge. It was actually an incredible session of learning. I hope you really enjoyed it. If you really did do that YouTube algorithm stuff, I'll try to correct my language when the stream goes. When I do multiple streams, hopefully I can able to correct my language. without any um, not a hesitation, without any um, struggling. I'll be able to deliver what I'm trying to. um, yeah, that's it for this stream. Hopefully we learned some new stuff. This is the time to sign off. So let me sign off. I'm trying to sign off. Yeah, I think fortunately I mean, surprisingly I got one chat, so I can realize someone is smart watching my channel. That is a good sign actually. That there should always be uh, uh, the recognition for the efforts that creators put. So yes, hopefully I will get some recognition in future. What else? Yeah, that's it. I'm signing off. Cheers, and I love you all. Thank you so much. I'll catch you next time in another stream.